Hi guys, today we're going to be talking about section 8.4, which is angles of elevation and depression. Now this is going to relate a lot to our previous lesson of trig. Our main idea, our main focus of today is when I see this vocab of an angle of elevation or depression, what does that mean in context of a word problem? Because that's what a lot of this is going to be today, is it's going to be a lot of word problems. So let's go ahead and start with that main vocab, starting off with angle of elevation. Now when you guys think of elevation, you might automatically think of how Denver has a high elevation, how airplanes have to fly to a certain elevation of a couple thousand feet over sea level before you can take out electronics, things like that. Eventually, it relates to a height. So an angle of elevation is going to be the angle that is made by a horizontal line of sight to an object that is above that line. That keyword there is above, just like elevation increases in height. So what I have for an example here is I have this person here on ground level and this person that is above them. The horizontal line of sight is what I see if I look straight forward. So that is your horizontal line of sight. An angle of elevation is going to be the angle that's created when you look at something above that line of sight. So this here is my angle of elevation. Okay? It's the angle that is created when I elevate my line of sight. Which will you can probably guess what the next word is going to talk about with angle of depression. Depression in math is a word that talks about something decreasing or going down. So it is going to be an angle made by the horizontal line of sight to an object that is below that line of sight. So I have the same picture of the person on ground level and the person up on the building, but depression is when you look down from your horizontal line of sight. So that would be the equivalent of the person looking back at his friend. So there is his horizontal line of sight, and if he looks down at his friend, then we call that an angle of depression because the angle is decreasing from his horizontal line of sight. Okay, so note that it's really important to think about elevation is going up, depression is going down, but that other part of that angle is always looking straight on. So for example, this person can have an angle of elevation if he looks straight up, but he can also have an angle of depression if you were to happen to look down. So make sure you are able to decipher between these two lines. Now before we get into how do I use these main ideas to solve the problems that we've been solving in trig, let's go ahead and just work on, can we identify what type of angle we're going to be looking at. So let's go ahead and take a look at problem 1, where it says describe each angle as they relate to the situation. So we have 4 different angles here. This is a picture of someone on the ground level of an airport, someone at the top of the airport tower, and then someone in the airplane, probably the pilot. There's 4 angles here. There's angle 1, 2, 3, and 4. We're going to go ahead and we are going to identify those as either an angle of elevation, an angle of depression, or neither. Okay, so I will do number 1 with you. Angle 1. Take a look at where angle 1 is. It starts here. That's my vertex. Here's my horizontal line of sight. Is that angle depressing or elevating? You should be saying that, oh, it's going down, so that's an angle of depression. Pretty easy, right? Okay, I'm going to go ahead and pause the video here in a second. I want you guys to see if you can, in your head, identify the other 3 angles as a depression, elevation, or neither. Go ahead and pause the video to try it out on your own now. All right, go ahead and check your answers for angles 2, 3, and 4. Again, for identifying each of these angles, we're focusing on is my horizontal line of sight and is my angle going above that line of sight or below that line of sight to an object. All right, So if you were not able to identify these correctly, you really want to make sure you go back and look at the vocab before you move on to the next 3 problems, because we're going to start talking about how can I use these angles, how can I use this vocabulary to find certain values in triangles with trig, which brings us to question 2. Let's go ahead and look at that. A surveyor stands 200 feet from a building to measure a height with a 5-foot-tall theodolite. The angle of elevation to the top of the building is 35 degrees. How tall is the building? Now, a theodolite, I want to be clear about what that is. A theodolite is a surveying tool that can be used to figure out angles to a certain object. You guys have probably seen these in real life before. They look like this. Okay, they're usually on a tripod of some sort, such as this one here. And they're manned by construction workers who set them in front of an object and use it to move and see what type of angle they're looking at. Here's an example of one in use where you look through the hole and you can just adjust this to your angle, and it tells you what angle you're looking at. So it's really useful in real life because it helps you tell you exactly what angle you're looking at without having to guesstimate or try to use other means. It's really focused. So that's what we're using here in this problem. And the angle that it reads for the elevation is 35 degrees. How tall is the building? So let's go ahead and draw a picture here to help us think about this problem. So we have a worker. We have a worker, and he has a theodolite. So I'm just going to draw like a tripod. Okay, there's my theodolite, and it says that it's 5 feet tall. So that's 5 feet tall. And it reads an angle of elevation to the top of a building. Okay, so there's my building. The surveyor is 200 feet away. And then it says the angle of elevation is 35 degrees. How tall is the building? Okay, so again, here's that vocab of angle of elevations, which means that the theodolite is reading from its horizontal line of vision above to the top of the building is 35 degrees. And so that's where that vocabulary is going to really come in handy, is instead of just saying it creates a 35-degree angle, it's saying that it creates this angle of elevation. So if you look here, we now have this triangle here that we can use to find at least this portion of the building. Now, we've practiced that before with our trig, and that's what we're going to do. So to help you guys visualize this, I'm going to go ahead, I'm going to redraw this triangle over here. Okay, this was a 35-degree angle. We don't know how tall this part is, so I'm going to label that X. And then this part represents the distance away, which was 200. Now from here, we're going to use trig that we learned in section 8.3. Looking at my angle, I'm looking at what are my opposite, adjacent, and hypotenuse. Okay, I know that my opposite is X, my adjacent is 200, and I have no hypotenuse given. So because I have O and A, I'm going to be using tangent for my ratio. So tangent of 35 degrees is going to be O over A, which is X over 200. Okay, using that, we now have an equation to help us solve for X. So you would go ahead and solve this the way that we practiced in our last lesson by multiplying by 200 on both sides. So whatever 200 times tangent of 35 is, will be our X. You have to use your calculator for this bit, but you're going to get about 140 feet. Okay, if I estimate that, I'm going to get about 140. But here's the question now, because this is where angles of elevation can have some withdrawals, is that this creates the height of X. But take a look at where our triangle was on our original problem. Is that this height does not cover the entire building. It covers from the theodolite's horizontal line of sight. So we have to add on how tall that theodolite is to make sure we have our complete height of the building, not just from the horizontal line of sight up. So we're going to go ahead and we're going to add the height, which we found out was 5 feet. So our answer is 145 feet. And again, we did that by taking our answer for x and we added the height of the theodolite to get the entire value. Okay, so our answer is 145 feet. So what's new in this question is recognizing that vocab to help us draw a picture. The trig is review from our previous lesson, and then making sure that you add that height back on that's underneath your line of sight. All right, if there's no questions, let's go ahead and move on to the next problem. We're going to practice some more word problems. So problem 3, Kyle stands 120 feet from the base of a tree. The angle of elevation from eye level to the top of the tree is 40 degrees. Kyle's height to his eye level is 5 feet. What is the height of the tree to the nearest foot? Now, what I want you guys to do is, because this is a very similar question from the previous problem, is I want you to go ahead and think about what this picture is going to look like. If you want to draw a picture on your own, go ahead and do that. If you want to visualize it, do that. But go ahead and think about what is this situation going to look like and what are these numbers going to represent. I'm going to go ahead and pause the video, visualize, or draw this now. All right, guys, this is the picture you guys should be visualizing. It might be flipped based off of your point of view, but you have Kyle on the ground. He's 120 feet from the base of the tree. His angle of elevation, so his angle looking up, is 40 degrees, and his height to his eye level is 5 feet. Very similar problem to question 2, just some different numbers here that we're going to be practicing with. So what we're going to do is we're going to, again, take a look at this triangle that we have. Okay, the triangle we have is right here. We're going to try to look for the height because I want us to find out the height of the tree. But again, keep in mind that this height that we're going to find here is not the entire tree. We're going to have to add that 5 feet back on at the end. Okay, so essentially we have this triangle. We're going to try to find the height x. We know the angle of elevation is 40 and the distance between the person and the tree is 120. Based off of that information, which ratio are we going to use? Well, I have my opposite and my adjacent, so just like before, I'm going to be using tangent. Okay, now I want to be clear here. You're probably going to be using tangent a lot in these word problems, but not every single time. So make sure you're being very careful about looking at what sides you have and then identifying which ratio you're going to use. So I have tangent of 40 is going to equal my opposite, x, over my adjacent, 120. So now you have this equation. How do I get x by itself? I'm going to multiply by 120. And I'm going to put 120 times tangent of 40 to equal x. You do that and round it, you're going to get about 101 feet, equaling your x. Now, just like before, keep in mind that's only the distance between the horizontal line of sight and the top of the tree. So we need to add in Kyle's height for the bottom of the tree, which was 5 feet. So my final answer is 106 feet. You might be starting to see about how this is a lot of problem solving and word problems in this lesson, so just be aware of that. All right, guys, last question, last word problem. A rescue worker is located 175 feet above the ground in a lighthouse. He spots a ship at an angle of depression of 62 degrees. How far from the base of the lighthouse is the ship? Round to the nearest tenth of a foot. So let's go ahead and think about what this problem is going to look like. We have a lighthouse. So I'm going to draw a lighthouse. Okay. And at the top of this lighthouse is a rescue worker. So we have the top of our lighthouse. Here's the rescue worker at the top of the lighthouse, right there. And he says that he is located 170 feet above the ground, so we know that he is 175 feet above the ground. And he spots a ship in the water at an angle of depression of 62 degrees. So here's the lighthouse, here's the water, here's the boat. And he says that he spots it at an angle of depression of 62 degrees. Now this is a different angle, remember? Depression is an angle looking down. So what this means is that from his horizontal line of sight, if he were to look down at the boat, it would be 62 degrees. Okay? This is really important to recognize what we're looking at here. And then it says, how far is the boat from the lighthouse? Round to the nearest tenth of a foot. So take a look at our triangle here. Okay, what values do we know? What values are we trying to figure out? We're trying to figure out how far is this boat away from the lighthouse. So that's going to be this value here. And then we're also trying to figure out, we also know that the complete height is 175, so I'm going to call this 175. You might be thinking like, hey, that wasn't completely at the same level. It's supposed to be. My drawing's just off. You can also think about this the other way, as if I were to use this triangle here, but you would have to use a different angle. So this is going to be our easiest way to do this. So here's our angle, 62 degrees. Just like before, we got to figure out what ratio am I going to use. I have my opposite is 175, my adjacent is my x, and I have no value for my hypotenuse. Hey, look, it's tangent again. So tangent of 62 degrees is going to equal opposite 175 over x. Now on this one, when we solve for this one, you guys saw in the previous lesson that because x is my denominator, it's going to give me a couple more steps to solve. So that means I'm going to multiply by x first to get rid of my denominator. I have x times tangent of 62 equals 175. And now I'm going to divide by tangent of 62. X equals whatever 175 divided by tangent of 62 is. And just like our previous questions, you're going to go ahead and take that and put that right into your calculator, which is about 93.1 feet. Okay, now in this question, I don't have to add anything back on because his angle of elevation is given to us at a point where they give us the distance from this to the ground. So I didn't have to add anything back on because it wasn't any further above the ground. I didn't have to account for anything above the ground with that line of sight. So we are actually done with that x value. And that is our last question of these notes. So as you saw, there was a lot of trig in this lesson. That's review from the previous lesson. What's new for this section is taking the vocab of elevation and depression and using that to do some problem solving with these different pictures. So go ahead, we are done for this section of notes. Go ahead and move on to the homework for this section, and I will see you guys next time. Have a great day. Bye.